to introduce you into the symmetric encryption. So what is symmetric encryption? Well, it has something to do where we XOR and multiply small numbers in order to encrypt a message. And encryption is widely used today and has been a very historic, fundamental way to communicate secretly with some allies you have in the field. Perhaps you're conducting a war. And let's look into who might want to conduct a war. But first of all, we also need to address that symmetric encryption is faster than today's asymmetric encryption, or in general, because asymmetric encryption compared to compared to XOR and multiplication of small numbers, which is symmetric encryption, well, asymmetric encryption deals with power, so lifting numbers up, and modulus. And because it deals with these types of method or mathematical operations, it makes the asymmetric encryption slower. And in general, it's faster than asymmetric encryption. So when we talk about the history I was just pointing out just before, well, we have, I don't know who you can recognize this person, but this is Cesar. And one of the first and most known encryptions, that was Cesar Ciphers. Cesar Ciphers uses a monoalphabetic shift. So, and what does that mean? Well, that means that if you want to encrypt a message, so you have a plain text, you say hello world, you want to obfuscate, like change the characters in this message so that if a attacker, somebody who you do not like, the barbarians, I'm not that good at Caesar history, but if somebody picks up that message while it is going from A, Caesar, to B, a general, well, if we shift every letter in the message with something that is not supposed to be there, well, and cannot be read, so the attacker or somebody who intercepts this message will not know that you are attacking tomorrow, perhaps, so, or attack at dawn. So we take and what we do is that with this monoalphabetic, like 26 characters we have in the alphabet, Caesar, he took every letter of his attack at dawn and then shifted A, T, T, A, C, C, K with another letter. And now comes the little fun part. He used perhaps a key, or he did use a key, and that key, that was the number 3. I'm not 100% sure that we have to say that, but let's just imagine he used the number 3. So he uses 3 as a key. So 3, because it's the key, it tells us an information about how many letters we should go from A and then say plus 3 and plus 3. So A plus 1 is B, plus C is 2, plus 3 is D. So every time an A occurs in the text attack at dawn, it will have to be shifted up to D. And likewise with T, we will add T plus 1, S, and plus 2. It's so on and so forth. So I hope you get the idea here. Then later on in the history, we skip forwards and we get the Vigenere encryption, which is more like today's encryption. And Vigenere encryption, well, it got famous because it was very hard to crack. It also uses an alphabet, but it uses alphabet in a more sophisticated way. So instead of just one alphabet you can change with, well, he uses a lot of more keys. So instead of just, and then he encrypts it with a letter. So if you have the number 3, well, you will have D at first, but then you will not only have 3, you will have a whole vector of different kind of keys. So compared to the Cesar cipher, so each letter in this key, which is a string of letters. So you have attacker dawn, and then you have meet me, and then or Swedish or Danish. So if you multiply each like a position of the letters in the order, so of the alphabet, so you have A and S, so Swedish. So we say A is or blue. So you say A, attacker dawn A is 1 and B is 2. So the difference here, you have to add the B to the A to get the ciphertext. Or yeah, so to get the right text. So in principle, that is more complicated than the Cesar cipher and was very hard to crack. So moving on to today, we have this called one-time pad of modern symmetric encryption. So one-time pad enforces the Vigenere of having a long text that works as a vector key, where each letter in the text is added to the original text or the plain text. And what one-time pad does, it must, and this is one very secure encryption method. So one of the things that makes it secure that the key size is equal to the plain text size. So these, they have to be, so attacker dawn has to be as equal as the same length as the key size. So, and then it's very important that we only use the key once. And also another factor that is very crucial is that it's a true random key that is generated. All the letters are generated randomly in order for it to be completely secure, and that it's the only unbreakable cipher of all currently. And it's heavily inspired by the Vigenere ciphers. So what is when we use this one-time pad is that we are very cautious, because one-time pad is really memory intensive. So because we have to have a key size that exactly the same as the plaintext size, what we encrypt, it has to be very memory efficient. Let me just give an example here. So I have a GIF picture here. So we're working. We can work in binaries, and we will perform XOR operations. So we have a ciphertext that is this text here, that GIF, and then we have the key GIF. So, and then these are texts, like if you convert them into a computer language, ones and zeros, we get some ones and zeros in this kind of pattern, as you see here. So this is a very visual example here. So we have the ciphertext. We use the XOR operation, so which is exclusive OR. So it will try to divide these, or at least we have the ciphertext and the key here. So the key will try to perform an XOR operation, or it will perform an, in order to decrypt the message, we have to perform an XOR operation on the ciphertext. So it will eventually filter out, and because it fulfills it, this is the same size, it's the same, and it's the key to the ciphertext. We will get this message when we try to perform an XOR operation on it. And XOR is exclusive OR. So also what is important to know is, one thing you have to keep in mind is that you have to keep, if you have any two messages, and that you must not, for security reasons, encrypt the same text with the same key twice. And this is why, because if you have, here we have the plain text 1 and plain text 2, and if we use the XOR operation with the key, so we have a key and we have this plain text, then if these two are intercepted and are XOR with each other, it will actually either the text or this one will work as a key, because what happens is that in these operations the key gets cancelled out because the key is the same. So here you will see down below here, you will the keys are being cancelled out. So what you end up with is actually the plain texts. So you have actually just the plain text here, and that is not very fortunate. That's a huge security issue with the one-time pad. And so the one-time pad is very rigorous in terms of security, and how we should keep the key secure, because you should keep the key very, very secure. You should and only use it once. So it's very impractical to use in reality, but it provides humongous security. So what we can go on to is something else that is called block ciphers within symmetric encryption. And this type of encryption encrypts block sizes of 128 and 256 bits. And one of the most known and secure block ciphers is the AES 120 block ciphers. And just encrypting with that is not very secure, and that's what you can use your hard disk to encrypt it with. Because when we come to encrypting this, we want to make sure that 100% sure that it cannot be very easily decrypted. And ECB, which is something a way to add some more encryption this is no way of adding more encryption to it, has been shown. So we have different kind of extra encryption to these some counter mods that modes of operation. So in order to add some higher level of encryption, has not shown to be secure, which has been used. So these more and what is this ECB? Well, I cannot remember the exact abbreviation, but what it is, it's a wrong mode of operation, and it can make the encryption algorithm insecure. And this is very important information. So what this really does is that it is the way that these the ciphers are carried on. So how you choose after in the encryption, you need to somehow store the ciphers correctly, and therefore you have these modes of operation to somehow to ensure that the ciphers gets stored correctly in some way. And this is and also another way of doing this is called CBC, and this is also shown to have some kind of integrity problems inherent. And what really is the essence of talking about modes of operation is the Vigenere Counter Mode. So this is shown to be the most secure way of modes of operation, and it provides enough integrity. And it has this initial vector that is used to ensure that the carrying of the ciphers is correctly done. So that is 128 bits long. So if you don't use proper encryption, well, what is bad is that, and also modes of operation, is that if a hacker, and this is from the attacker's viewpoint, so in modern IT systems, they are able to use this tool called aircrack, and they can actually see in plain text what is going on inside in your communication. So they will have able to unlock your secret communication, and they will be able to monitor and read what your passwords. So, and this can be easily done with VEP, which is used in Wi-Fi, old Wi-Fi encryption standards. So this is very insecure. So thank you for listening. The next topic is going to be asymmetric encryption. So I suggest that you should keep on watching here on my channel.